All right. So everyone can see here, again, happy Friday, by the way, happy Friday. We've got our little wave diagram. We've got to label that. And then 2, what type of star is the sun? And then 3, what are the 2 outcomes of a massive mass star? So let's see, Angel, did you by chance want to maybe answer one of those for us?
I said number 1, 8 is Taurus, B is Amplitude, C is wavelength, and D is trough.
Perfect. So for number 1, everybody, and Jernisha, did you need more time to write the last question? No? Number 1, we had A was crest, B was amplitude. That's, again, crest is the top. The amplitude is the range of it going up and down. The wavelength is how far it moves from side to side. And then lastly is the trough, which is the lowest point of the wave, All right, so make sure, again, we'll go at the pace of my in-person students. And then number 2, let's see, Angel, did you remember from the other day what type of star the sun is? It is a yellow star. It'd be easy to say dwarf. Okay, hold up, Joseph. No, those are all the answers. Those are all actually the answers. So yes, it is going to be actually a yellow main sequence star. So for number 2, what type of star is our sun? It's a yellow, less massive main sequence. So what do I mean by that? I mean, it's not like a giant. It's not a dwarf star. I'd say it's a little below medium, right? Okay, make sure you guys can hear me on the computer here. Okay, and then number 3, we've got what is going to be the end result of a giant star? So on the life cycle sheet, Angel, did you happen to have that one as well? What are the 2 results that we could get from a giant star? Yep. So it's going to be a supernova, which creates a black hole. What's the other star? Perfect, exactly. So black hole or neutron star from a supernova. That's only for giant stars. So our sun, our star, will not become a black hole. It will not explode. It's just going to fizzle out. But the giant stars, those are the ones that make black holes and neutron stars as well. Okay. Any questions, everybody? Any questions? We're all good to go? All right, let's move on. Again, that was from the diagram the other day. We're good on that. We are good on that one as well. Okay, we did that yesterday. Go ahead and update your table of contents to pages 16 and 17. Update your table of contents. I'll give some extra time today because with our in-person students, they'll be getting them up to date with things. Give me one moment. I'm just going to check a few other things while you guys are doing that. I'll give you plenty of time to be quiet when you full credit given the situation that's going on. Yeah, it was the new machine. Yeah, so if you get problems and stuff like that, I'll still bring a lot of stuff. A lot of that stuff that you can go. So bear with me on that. Ready for your first practice question of today? Here in a moment. Again, make sure we participate in the question so that we get the participation credit, which I will be putting in as a large grade here at the end of the quarter here very soon, the next 2 weeks. All right, one moment, everybody, one moment. Okay. Let's see, period. Last period. Oh, my bad. 1 second, everybody, trying to find my question here. Here we go. Okay. Let's take a look here again. Do our best on this one. You're going to answer in the chat what your answer is going to be, what you think is the right one. Again, if you do not answer, that affects our participation, correct? Okay. Let's see if it loads here. One moment. Here we go. Low mass stars will typically have a lifespan of how many years? So if you go to the bottom of yesterday's note sheet, you would see how long. Again, the idea is with low mass stars, how long do they typically live? So small stars, how long do they live? Is it A, thousands of years, B, millions of years, C, billions of years, or D, trillions of years? As you can see, Angel's at the bottom of this sheet right here. You'll see. You can jump out. If you like. Please answer in the chat for my online students. All right. Great job, ladies. Great job. Great job. Those of you online, again, let's see what you have in the chat here. Okay, let's see. I'm going to give you guys 10 more seconds. We've got Joseph, thank you. Daniela, Isaac, Irina, Sanaya. I got 10 more seconds, everybody. 10 more seconds. All right, Yorkies, thank you. Lakia, thank you. Okay, let's go ahead and see what we've got here. I've got my in-person students saying D trillions, and that is correct. So shout out and props to Jeranisha, Angel, Yorkies, Lakia, Diego, Irina, Isaac. Great job, everybody. Again, the smaller the star is, the longer it lives, right? Think of it like a car. It uses up less gas, so it can go farther away. Whereas like a Hummer, the larger the star is, the earlier it dies, the shorter it lives because it uses up all its fuel and all its gas. Like a Hummer can only go 10 miles per gallon, whereas a small car like the one I've got can go 30 miles per gallon. So they have to fill up their gas tank like 3 times as much as I do. That's a tough situation. All right, let's do our only video questions of the day. Next, we've got here, we're going to get into our star diagram. Before we do that, I want to kind of get an idea as to what we're going to be looking at when we do draw that in our notebooks. So on page 16, I need you to write these 2 questions. Number 1, what characteristics are analyzed to classify stars? So like, are we going to look at their color? Are we looking at their size? Are we looking at the temperature, how bright they are, how far they are? What characteristics do we look at? There's 2 of them of those I said. Which 2 are the most important? And then number 2, I think you guys might already know this one. What star color is the A, hottest star color, and B, the coolest star color, right? Remember, there's red stars, yellow stars, blue, white stars. So of those 4, which is the hottest, which is the coolest? So write those questions down on page 16. We'll move on as soon as our in-person students are ready. And did either, ladies, either you have an idea as to what you might think for the second question? The hottest star versus the coldest? That's a good idea. If somebody's saying blue, that's a good idea. Like what we're thinking there. Anyone think they know what the coldest is? Okay, we'll find out here in a little bit. Think of like a flame, right? Think of a flame. When you guys are all ready, we'll get it going. I've had students that keep telling me that I'm the only class that still has them having like a quiz or a test next week. Is that the truth? I think because the history exam, you guys are all done, right?
Yeah.
Okay, it's for Belazaire, right?
Yeah,
Okay.
I have to make mine up.
Oh, maybe tell me that. Yeah. All right, well, let's go ahead and begin our video. My in-person students are ready. Again, believe it or not, in the video, I skipped through a little bit, but the number 2 is going to be answered first, and then number 1 is answered after that. So let's go ahead and check it out here. All right, hold on. Let's go ahead and take a look. We'll start right about, hold on. Okay, no. All right, so number 2 is going to get answered right away after this. And then number 1 happens a little later when they show the chart. Let's check it out.
Getting cooler still, some bands show up that correspond with metals, like calcium. So the convention is derived from temperature, but this happens to correlate with color and size as well. Hotter objects, like O and B stars, are blue, and cooler objects, like K and M stars, are red. Also, hotter stars tend to be larger and burn brighter, with the additional heat resulting from the fact that so much more fuel is being burned. All of this data regarding temperature and luminosity, as well as indirect information on mass and radius, can be represented on something called a Hertzsprung-Russell diagram, or an HR diagram for short. In this diagram, the horizontal axis shows temperature decreasing to the right, and the vertical axis shows luminosity, or the amount of energy emitted by a particular star per unit time, increasing going up. We can see that the majority of stars fall on a continuous curve, which we call main sequence stars. 90% of all stars follow this trend, including our own sun, which is part of this yellow region here. Some stars, like red giants, are very cool yet luminous, while others, like white dwarfs, are very hot yet dim, but the majority belong to this main sequence. Even though this diagram lists only temperature and luminosity, we can infer many things about other variables. Larger stars are always more luminous, as more surface area means more energy emitted. We can also see color clearly correlating with temperature as we move from left to right. Size is also represented, with main sequence stars decreasing in size from left to right, but with red giants and white dwarfs deviating from this trend. This data.
All right,
collected
so
by
a really
looking
good
at-
breakdown of the diagram we are going to draw, and my students in person are going to label here in a little bit. So make sure you have your phones ready for that. But let's go back to our questions here. Number one, what were the two characteristic ladies that were analyzed for how we differentiate different stars? Temperature and luminosity, right? What was the unit? This is a test question. What was the unit used for temperature? Was it Celsius, Fahrenheit, or Kelvin? It was Kelvin, right? And then, Jerry Nisha, did you see what exactly is luminosity? It's what a star is. A good guess? No, good guess. Not hot or cool. What is on a hot summer day? What does the car paint do? It could turn color, or it could be really what? Or if you're driving towards the sun, it's gonna do what? It's brightness, right? Great. It could be too bright to drive, right? So luminosity is brightness. Just wanted to quiz you guys on that before I gave it to you. Luminosity, just know it's brightness. That could be a quiz question or a test question. Make sure to add that down. And temperature, Kelvin. And then Jared Nisha, what's the hottest star color and the coldest again? So those are the letters, right? We're not going to need to worry about the letters, but if you went technical, that is true. So what colors, though, were the hottest and coldest? So good guesses. The hottest was going to be actually blue, like you said earlier, and the coldest is red, right? Red. So easy to get. You think red's always the hot color because it's like fire color of fire, right? Well, actually, if you look closely at a strong flame, the middle of it, the inside of it, or the center right out of the source is usually blue, right? Because that's the hottest part of the flame. So blue is the hottest of star colors. Red is the coldest, believe it or not. Red is the coldest. So when my in-person students are ready, I'm going to give them a few minutes to set up their diagrams while you guys take a picture and draw these on your page as well. So looking at that, let's correlate that back to our diagrams then. Super important. My online students, you guys are basically just going to kind of draw a bunch of circles and color them however way you'd like. But take a look here. Okay, so what I need you guys to do is you're going to go ahead and take a picture of this and then kind of draw it the best you can to scale on your page 17. Page 17. Again, don't be surprised if this is something I asked for on a notebook check. I'm going to give you guys about 1 to 2 minutes, maybe 2 minutes probably, just to label this and color it if you'd like. I've got coloring utensils over here. In my in-person class. Something important to note, really, really important to note, you need these labels on your diagram, hottest, brightest, coldest sun, but you also need this title right here. Really important, guys. We need to know that this is called a Hertzsprung-Russell diagram. So at the top, make sure to write Hertzsprung-Russell, because that is one of our test questions. Hertzsprung-Russell. I'm going to wait till the in-person students are ready. Then we'll move on to our last activity. And we'll do maybe a review question and then call it a day. I'll give you guys the rest of the class to get some of your work done, get caught up. Okay? You have a question, let me know. We're going to take a 2-minute intermission. Take a picture. Feel free to start drawing this on page 17. Again, waiting till our in-person students are ready. Only colors you'll need if you want to color are blue, red, and yellow. Blue, red, and yellow. Other things to include as well. Again, just know that blue stars are the hottest, we just said, but white is the second hottest. White stars are the second hottest. We have white dwarfs down here. What stars are more bright, ladies? Is it going to be the giant stars or the dwarf stars? Giant stars are the brightest, But what advantage do dwarf stars have? They live what? Live a lot longer. They're more efficient. Okay. Coldest is the red, and just know again, the sun is a yellow main sequence. Sun is the yellow main sequence. I'm going to keep that up there, and when my in-person students are ready, we will move on to our next activity. Again, if you're online, please take a picture. You'll be drawing this on page 17. We'll move on here when they are ready. Anybody got weekend plans besides recharging for the next week? Yeah, it's that time of year. We just got to finish the school year, right? Just got to finish the year.
Wait, if I put all the makeover on his school, do I still have to go to that summer school thing?
Oh, I don't think so. If you get the credits for it, you're good. I think, yeah, because like I said, I'm gonna grade for full credit. So just get it done in the next 2 weeks. You'll be all set. You'll be on equal footing with everybody else. Because you weren't gone for no reason, right? It was out of your control, So like I said, I'm gonna be flexible with it. I think we have some quizzes and tests to make up. I may let you for one of those tests use the notebook because again, it's been a long time for some of that stuff, so I want to make sure. But like I said, you won't have the group test with it. That's the disadvantage, but you get the notebook probably with it. So okay, let's go ahead and continue, everybody. Any questions on this diagram? Again, it's charting stars based on their size, how hot they are, and how bright they are, right? Okay, let's move on then to, we're not going to do research time because we are not together in person. If you guys recall, and let me pull this up here, we were on page 15. So you go to page 15, ladies, and let me go ahead and give this to you. Let me show the online classes. Go to page 15, and yesterday, it's the last activity, everybody, before we do a question. Let's see, stop share, hold on. So you guys can see my camera here. All right, so yesterday, I'm going to show this to the students, Jernisha, then I'll give it to you. We did 7 star types, right? Star examples. We had protostar, red dwarf star, white dwarf star, black holes, main sequence, red and blue giants, and then neutron star. Okay, so we are defining these and describing these in like one sentence. So we already did protostar. Again, if you want to take pictures of this, you can go. It's already on the video I posted yesterday on YouTube. Again, so just to show what we're doing today, we're going to finish 3 more of these today. So just take a picture of that if you want to know what's going on today. And I will go ahead and give you those descriptions right now. If we were in person, I would give you research time, but I don't see the point. If we're online, I might as well save us more time for later and just go through it with you right now. Okay, so we'll do 3 right now, and then we'll do another 3 another day. Like I said, everybody, I've got like 6 or 7 more days left of this lesson, of this unit. I'm trying to get it done and like condense it into 3 more days instead of 6. So I'm trying to like cut it in half to make sure we finish at a better time and date, right? So let's go ahead. Let's go back to our screen here. We did protostar yesterday, right? And if you didn't already have protostar, you can write that there, Jernisha. And if you don't have that, write that there. There's the definition of protostar, everybody. And this is, so we're going to go over really quickly a red dwarf versus a white dwarf star. Okay? So if you think about it, a red versus a white dwarf star, Angel, what would be the obvious difference there? Red dwarf versus a white dwarf. Oh, absolutely right. Which means that they're different in what? Which one's hotter? Which one's cooler?
The red is cooler.
Yep.
And the white is
Much hotter, right? Much hotter. So for red dwarf, this is pretty easy. We'll just say this for red dwarf. Okay. For red dwarf, we'll just say this: a small red and relatively cool star on the main sequence. So again, say I have a quiz question and ask you, what is the difference between a red dwarf and a white dwarf? They sound pretty similar, right? Well, here's the key thing for the red dwarf. It's cooler on the main sequence. They're quite common. They're a pretty common star out in the universe, okay? But just know it's small, it's cool on the main sequence, okay? We're going to do 2 more for today, and then we'll do our last question and call it a day, everybody. Wait till my in-person students are ready. And typically, like I said, we would have researched, and I'd have my students in person. They would kind of give me like a rundown of what they found. But because of time and efficiency with you guys online, I'm just going to go ahead and walk you through it. So not ideal for me, but I think easier for you and just to save us some time here. All right. So white dwarf, if you didn't know already, I'm going to wait till we have everyone ready. Okay. Got two more. Sorry to make you write fast, guys. No rush. Take your time you need to. So white dwarf, we'll just say this then instead, okay? They're obviously hotter, but red dwarfs are independent stars. White dwarfs are usually the leftovers of stars that have died, right? Stars that have died. So they are much hotter, as Angel said earlier, because we know that white is actually the second hottest colored star behind blue. Okay? And like I said before, our star, the sun, this is probably what it's going to end up being. It's probably going to end up as a white dwarf. Okay? It's going to become a red giant and expand and then fizzle out and leave only the core left over. Okay? So it leaves over a bunch of stardust and then the core gets left over and that burns for a longer period of time. Again, it's like the leftover core of the star. Okay? So again, red dwarfs they're just small, they're cool. There's a lot of them. But for white dwarf, we just got to know it's a leftover star that just has its core left over. This is probably what's going to happen to our sun eventually, right? A few billion years. Okay. What do we know about what do black holes do, guys? Yeah, black holes are going to consume everything in their path. So last term of the day, everybody, we got black holes, which we're going to see a lot more videos in the future talk more about. This is just a gravitational well. Again, what kind of stars are the only ones that form these, ladies? The giant stars are so our star will not become a black hole. No worries. Okay, and like I said, it's a massive star that has died, and then it forms a gravitational well that consumes everything around it. So think of it like a drain in space, like a space drain or a space garbage disposal. It takes in all the light, takes in all the dust, the gas, the material, and just destroys it to nothingness, right? So it destroys it to nothingness. Okay, nothing can escape it, right? Nothing can escape. It consumes light, consumes matter. All right, let's see. I'm going to have one more question, and we'll call it a day, everybody. One more question. Anybody have questions? We'll do our last card question of the day. And ladies, just so I can give you some bonus as well. I'm going to write your name on the card instead of with the question. That way I give you once a week. Don't forget. Okay. Let's see. Okay. One moment, everybody. One moment. We have one more question. We are done with our notes for today, everybody. We have one more question, though. Okay, 1 second. Almost ready. Trying to find a good question here. Let's see. All right. We'll try this one. Okay, and it's based on the chart we just did, right? Let's see. Question. Right. Okay. Wanted to find one that related to today. Didn't want to show one that was just from way back last week, maybe. All right, last question of the day, everybody. Which of the listed star types is the brightest? A, blue giants, B, red giants, C, white dwarfs, and D, main sequence. I'll say this as well. It's the brightest and the hottest. So it's got to be brightest and the hottest on this list. Which of these four is it going to be? Which of these four is it going to be? See what you got. Write your name and your answer on your card, A, B, C, or D. in the chat. Again, it's going to be the hottest and it's also the brightest, if that helps you. It's the brightest and the hottest. Okay. Thank you, Joseph. Thank you, Lakia. Take about 15 seconds, everybody. Hottest and the brightest of the list of these stars. Hottest and the brightest. All right. We done with our cards. I'll take those. We need bonus for being here in front of here. All right. Awesome job. Awesome job. Both got it right. Give you 3 bonus points for that. 10 seconds for my online students. 10 seconds. Goes to the quarter 4 grade participation. All right. 5, 4, 3, 2, 1. Thank you. Let's see. Do those answer? Diego, Isaac, Sanaya, Irina, Yorkies, Lakia, Joseph. Thank you for answering. The correct answer, everybody, was going to be letter A. Blue Giants are the hottest and the brightest. Blue Giants, right? Hottest and the brightest. Props to Joseph, Angel, Jeranisha, Lakia, Yorkies, Irina. We're getting the right answer. Great job. Great job. All right, everybody, let me go take attendance, and then I'll make an announcement. You guys will head out for the weekend. Do not sign out yet. Do not sign out yet.